Hi once again. So for this video, we'll continue our discussion on number system, but this time we'll learn how to convert any number to decimal. So to start off, let's learn how to convert binary number to decimal. So any number or any binary number can be converted to its decimal equivalent simply by summing together the weights of the various positions in the binary number which contain a 1. So just like our previous video earlier, you remember that it's like 1 is like switching it on and 0 is like switching it off. So just take note of the ones and take note of the binary bit equivalence that is displayed below, starting from the right. So we start off with 1, 2, 4, 8, 16, 32, 64, 128, and you can even proceed to 256 and so on and so forth. So just multiply the previous number by 2. So if you're having a hard time remembering that, you can just multiply 1 by 2, and then 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, and the list goes on and on. So just multiply it by 2. So for you to be able to easily understand this, let me give you an example. So let's say that you're trying to convert 1010100. Alright, so if you think about it, the rightmost digit here, which is 0, is your placement number 1 or rather placement number 0, which is equivalent to a value of 1. So position 0, position 1, and then 1 here is position 2, which is equivalent to 4. So as you can see here, now so try to convert this one from the rightmost side. So 0 is equivalent to 0, so any number multiplied by 2 to the power of 2 is 0. So just put in 0 if it's already 0 there, and then just put on another 0 here for the second value from the right, and then you have 1. 1 here is on position 2. So remember that the rightmost number has a position of 0. So 0, 1, 2. So have a look at this. Position 0, 1, 2. That's equivalent to 4. So you have 4 here. And then the next one comes at position number 4. So this is 0, 1, 2, 3, 4. So if you look at the chart here, position 4 is equivalent to 16, and that explains why you have 16 here in the next row. And then again you have a 0, so just put in 0 there. And then you have the last or the leftmost one, which is at position 7. So if you look at from the right side, you have position 0, 1, 2, 3, 4, 5, 6. Sorry, position 6. So that position 6 is equivalent to 64. So that's why you have 64 here on the next row. So to make it easier for you, try to ignore positions 0 here. So that would be only 1 at position number 2. So that's equivalent to 4. Another 1 here, which is at position number 4. So that's 0, 1, 2, 3, 4 is equivalent to 16. So that's why you have 16 here. And then the last number 1 that you can see on this problem is the one at position 0, 1, 2, 3, 4, 5, 6 at position number 6. And as you can see on the chart, at position number 6, that's equivalent to 64. So just add up 64 and 16 and 4, and you get 84. Now that 84 is now your equivalent in decimal for your binary 10101000. Alright, so this is option number 1 in computing for your equivalent binary number to decimal. Now, if you have a calculator, if you are allowed to use a calculator, the other option for computing the same digit, okay, if you remember our problem is 1010100. Your other option is to do this. So the first one, which is on the leftmost side, is computed as 1 times 2 to the power of the position of that digit. So starting from the right, you have position 0, 1, 2, 3, 4, 5, 6. So that would be 1 times 2 to the power of 6. And then you add it up with the other digits. So if you want to be very particular about it, if you want to understand how it works, the next digit is 0, and if you multiply 0 times 2 to the power of 5, now again, why 5? Because starting from the right, it's position 0, 1, 2, 3, 4, 5, so that's why it's 0 times 2 to the power of 5. Now if you ask why 2, because we're trying to solve from binary to decimal, and binary has a base of 2. So 0 times 2 to the power of 5. Now remember that any number multiplied or 0, any multiplied to any number is always 0. So in essence, even if you're not going to do this numbers that is represented by 0, you will still get the same result. Alright, but okay, let's just go over this just for the heck of understanding how this one works, or how this one is computed. So the next value is 1 times 2 to the power of 4. Again, why 4? Because this 1 here, this number 1, is at position number 4. And then you have 0 times 2 to the power of 3. So again, this is because this number 0 is at position number 3, starting from 0, 1, 2, 3. And then the next number is 1 times 2 to the power of 2. Again, because this is at position 2, starting from the right, 0, 1, 2. And then the 2 remaining zeros are at position 1 and 0. So if you're going to compute 1 times 2 to the power of 6, that's equivalent to 64. 0 times 2 to the power of 5 is 0. Again, any number multiplied by 2 is always 0. So 16 is the next value here, and that comes from 1 times 2 to the power of 4. The next one here is 0 times 2 to the power of 3, which is 0. And then the next one is 1 times 2 to the power of 2, that's equivalent to 4. And these last two numbers are both equivalent to 0, because 0 times 2 to the power of 1 and 0 times 2 to the power of 0 are both equivalent to 0. So 64 plus 0 plus 16 plus 0 plus 4 plus 0 plus 0 is equivalent to 84. Now, simply speaking, if you only look at the positions of your numbers, the number ones, you will still get the same answer. So look at the first one here on the leftmost side of your problem. That is at position number 6. So 0, 1, 2, 3, 4, 5, 6. So that's 1 times 2 to the power of 6. That's equivalent to 64. The next number 1 is at position number 4. So 0, 1, 2, 3, 4. So that explains why it's 1 times 2 to the power of 4, which is equivalent to 16. The last one that you need to compute that has value, or that has essence, is the last one here that is at position number 2. So position number 2, because this is position 0, 1, 2. So 1 times 2 to the power of 2 is 4. So 64 plus 16 plus 4 is 84. So comparing these two solutions, they both get the same answer. Both are correct, but this one is a shorter way to do it. Now, for the next number, or for the next problem, it's 101.10. Now notice it has a decimal part. Now you need to convert this binary number to decimal, and to do that, because this time you have a decimal part, let's start with the first value here, which is 1. So 1 times 2 to the power of 2, again, because you start with the whole number, that's position 0, 1, 2, so 1 times 2 to the power of 2. We don't need to compute for 0. Let's look at the next value, which is 1 at position 0. So 1 times 2 to the power of 0. And then on the decimal part, starting from the decimal point, you now need to multiply your 2, or you put the power of negative numbers. So that's position -1, -2, -3, -4, and so on and so forth, no? And up to where you can find the number 0. So since the first digit 1 here is at position -1, so again, starting from the decimal point, you start looking at it at position -1, and so that's 1 times 2 to the position of -1, so 1 times 2 to the power of -1 is 0.5. The next digit here is 0. That would have been 0 times 2 to the power of -2. But again, any number that's multiplied by 0 is always 0, so we don't add that up anymore. So we compute this. So 1 times 2 to the power of 2 gets 4. 1 times 2 to the power of 0 is 1. And 1 times 2 to the power of -1 is 0.5. And so if you add that up, you get 5.5. And that is now your equivalent decimal number from your binary equivalent, which is 101.1. Okay, I hope you got that one very clearly. Okay, let's move on to the next conversion, which is octal to decimal. So to convert from octal to decimal, you multiply the value in its position by its octal weight, and then you add each value. So if you remember in the previous example, we multiplied it by 2 because we were trying to convert in binary to decimal. So binary has a base of 2. Now this time, octal has a base of 8. So that explains why if you're going to convert octal 24.6 to decimal, okay, remember that 8 here means octal. So during the exam, I will not anymore specify convert this from octal to decimal, because 8 there already means this is in octal form and you need to convert it to decimal. So remember, 2 is for binary, decimal is 10, your octal is 8, and your hexadecimal is 16. So okay, let's go back to the problem. 24.6 in octal form. So let's look at number 2. Number 2 is at position number 1. So again, 4 is at position 0, 2 is at position 1. So 2 times 8 to the power of 1. And then 4 is in position 0, so that's 4 times 8 to the power of 0. And then again, 0.6, or rather 6 is at position -1. So we add 6 times 8 to the power of -1. And that will give you 8 to the power of 1 is 8. So 2 times 8 is 16. Okay, now 8 to the power of 0 is 1. So 4 times 1 is 4. And then 6 to the power of -1. So 8 to the power of -1 is 0.125. So multiply that by 6, you get 0.75. And then you add up 16, 4, and 0.75. You get 20.75. And that is now the equivalent decimal form of your octal 24.6. Okay, now let's move on to the next problem, which is 315 in octal form to decimal. So again, 3 times 8 to the power of 2, because 5 is in position 0, 1 is in position 1, and 3 is in position 2. So 3 times 8 to the power of 2, and then 1 times 8 to the power of 1, and 5 times 8 to the power of 0. We again compute So 8 to the power of 2 is 64 times 3 is 192. 8 to the power of 1 times 1 is 8. And then 8 to the power of 0 is 1. Multiply that to your 5 and you get 5. So 192 plus 8 plus 5 is 205 with a base of 10 representing decimal. Again, that is your equivalent decimal value from your 315 octal value. Okay, now if you want to review the computation and the explanation, all you have to do is to rewind or pause this video and try to compute things on your own. Okay, now the next one, and this is not letter A but rather letter C, is the conversion from hexadecimal to decimal. So again, to convert from hexadecimal to decimal, just like your binary and your octal, in this case we multiply the value in each position by its hexadecimal weight, which is in this case 16, and then we add each value. So for instance, you have 2AF.6 in hexadecimal to decimal. So remember that of course here 2 is still 2, A is 10, F is 15. So that's 2 times 16 to the power of 2. Again, looking at the position of F, that's position 0, A is position 1, and 2 is in position 2. So 16 to the power of 2. So that would be 256 times 2, you get 512. The next value is A. A is equivalent to 10. So times 16 because it's hexadecimal to the power of 1 because this is in position 1 starting from letter F. F is in position 0. So that's 16 to the power of 1 is 16 times 10, 160. And then of course we already know that F is equivalent to 15 and it's in position 0. So that would be 15 times 16 to the power of 0. Any number raised to the power of 0 is 1. So you have 15 times 1 is 15. And then looking at the decimal part, which is 0.6, 6 here will be multiplied by 16, just the same. But since it is the first digit after the decimal point, that will be in position 1. Okay? Again, I'd like to emphasize, if you have another value following 6, let's say you have number 5, that will be position 2, negative 2. If you have another third digit there on the decimal point, that will be position negative 3. Alright, so in this case we only have 6, so that will be position negative 1. So that would be 16 to the power of negative 1 is 0.0625. Multiply that by 6, that will be 0.375. We add up all the numbers together, 512 plus 160 plus 15 plus 0.375, and that will give you 687.375 in decimal form. Alright, now so the next problem should be very easy for you. That would be 8, and D is equivalent to 13. So that would be 8 times 16 to the power of 1. It's position 1. And then D is in position 0, so that will be 13 times 16 to the power of 0. That will give you 128 and 13. You add them together, you get 141 in decimal form. Alright, so let me summarize that. We learned how to convert all numbers to decimal, binary, octal, hexadecimal. We learned that if you want to convert binary to decimal, we need to multiply it by 2 to the power of its location. If it is a whole number, we start at the rightmost digit, that will be position 0, and then going to the left, that will be position 1, 2, 3, 4, and so on and so forth. If it is a decimal part, we start at position negative 1, and we multiply that by the number times 2, okay, because 2 is the base value of your binary, to the power of its location, negative 1. And if you have more digits to the right, that would be -1, -2, -3, depending on its position. And if it's octal to decimal, we simply do the same, but since it is octal, it has a base of 8, and so we do the same thing using a base of 8. And for hexadecimal to decimal, that's also the same thing practically, but this time we use 16, not 8, not 2. So guys, I hope you learned from this video. Thank you very much.